Welcome students in the organic chemistry lecture series. In previous video we have seen about the elimination reaction. In that we have started with E2 elimination, that is one of the type of beta elimination reaction. Today in this video we are going to study about the E1 elimination reaction. Okay. Now you know that elimination reaction is the reaction in which an atom or group is eliminated from the molecule without being replaced by another atom or molecule. And beta elimination is the elimination in which halogen from alpha carbon and hydrogen from beta carbon is eliminated. Okay, so this E1 mechanism is generally observed. E1 elimination is observed if the starting material is tertiary alkyl halide like this. Okay, that means if tertiary alkyl halide is there and if that tertiary alkyl halide is subjected with base, then we got the E1 elimination product. So I will take one example of this E1 elimination. See, if I take tertiary butyl bromide CH3C CH3 Br CH3, and if we treat this tertiary butyl bromide with base, then we get elimination product like this: CH3 C CH3 double bond CH2 plus water and Br minus. Okay, so this is the example of E1 elimination reaction. So this is tertiary butyl bromide, remember. Okay, so if instead of tertiary butyl bromide, if we take simply ethyl bromide CH3CH2Br as I taken in the previous video, then in that case E2 elimination is occur. But if we take tertiary butyl bromide, then there is a E1 elimination reaction. Now why this depends upon the starting material, that will be understood by studying the mechanism of this particular reaction. Because why tertiary butyl bromide gives E1 elimination, that can be studied there. Okay, so if we consider this reaction, then it is observed that the rate of this reaction is proportional to only concentration of tertiary butyl bromide. Okay, the rate of this reaction only depends upon concentration of tertiary butyl bromide. So we can write rate is equal to K into concentration of CH3 3 times CBr. Okay, so rate is only proportional to concentration of alkyl halide and rate is not proportional to concentration of base. So from this rate equation we can say that the reaction is first order. From the rate equation we can say that reaction is first order. Okay, why it is first order? You see this rate equation and you will observe from this rate equation that the rate of this reaction only depends upon concentration of this tertiary butyl bromide and it is not depend upon the concentration of base. That's why we can say that the reaction is of first order, hence it is called as E1 elimination. This 1 stands for first order and E stands for elimination. Okay, so it is monomolecular reaction, therefore it is called as first order elimination reaction, that is E1 elimination reaction. Okay, so I think this E1 elimination reaction is understood to you. So I will once again repeat, E1 elimination is observed if the starting material is tertiary alkyl halide The example of this reaction is tertiary butyl bromide is reacted with base, then there is a formation of alkene. The name of this alkene is propylene. 3 carbons are there, 2 methyl propene, 2 methyl propene. Okay, so if we study this reaction, then it is observed that the rate of this reaction only depends upon the concentration of starting material, that is tertiary butyl bromide, and it is not dependent upon the base used. That's why from the rate equation the reaction is first order reaction, hence it is called as elimination unimolecular or monomolecular elimination, that is E1 reaction. Now we will see the mechanism of this reaction. Okay, in mechanism, a two-step mechanism is proposed. A two-step mechanism is proposed. Okay, now we will see one by one. Two steps involved in the mechanism. Step 1, first of all we will see. Okay, so what is step 1? Step 1 is tertiary butyl bromide ionizes. Tertiary butyl bromide ionizes to give tertiary butyl carbocation. So this is the first step. So I will write the reaction here. So this is tertiary butyl bromide CH3, CH3, and here it is bromine. So the first step is slow step. Remember, it is slow step. In this slow step, what happens? This bond between carbon and bromine gets ionizes, because you know that the bromine is more electronegative as compared to carbon. The bromine is more electronegative. That's why this bond becomes polarized. So here bromine, this bromine will acquire partial negative charge, and here this carbon will acquire partial positive charge. So this is the transition state 1 in this reaction, and then this transition state is very unstable. That's why finally we get the carbocation intermediate like this. Okay, so here is a positive charge plus bromide. So this is the first step. So what happened in the first step? In first step, tertiary butyl bromide ionizes to give tertiary butyl carbocation. Okay, through the formation of transition state 1. This step involves the breakage of this carbon and bromine bond, which requires energy. Hence, this is a slow step, and the carbocation intermediate is generated. Okay, now we will see what is the step 2 in this mechanism. Step 2, the carbocation intermediate which is generated in this second step, we have to take that. So what happened in second step? Base abstract the beta hydrogen of carbocation to give alkene. Okay, so this is the second step. So I will take this carbocation once again. I will write here for the sake of understanding. CH3, CH3. I will write one hydrogen here. Okay, now what happens? See, here is a positive charge. So this is carbocation intermediate. So we have hydroxy base in the surrounding. So this base abstract this proton. Okay, and this bond gets shift here. Okay, so this step is very fast. Okay, and here we get second transition state in this way. See, first of all, write down the as it is bonds CH3 and CH3. So these bonds are as it is, there is no change, but this bond between this carbon and hydrogen is going to break. OH here also this bond is going to form, and here also double bond is going to form. So here there will be delta positive charge, and here there will be delta negative charge. Okay, partial positive and partial negative charges, and then this transition state 2 is very unstable. That's why we get finally a product CH2 double bond C CH3 CH3 with the elimination of water molecule, and we know this is 2-methyl propene, which is our product, So you find that here what happens in the second step, the base which is present in the surrounding abstract the proton, okay, and this bond gets shift here. The step is very fast, we get second transition state, okay, and the transition state loses a molecule of water to form the 2-methyl propene as a product, okay. And you know that in multi-step reaction, in multi-step reaction, a slow step determines the rate of reaction rate. That's why here this step 1 is a slow step, and from this slow step we observed here that the rate of this reaction only depends upon the concentration of this alkyl halide. That's why the reaction is of first order only, okay. So I hope this mechanism is very clear to you. Now I will draw the energy profile diagram for this mechanism. Draw the energy profile diagram, okay. So these are the two axes, x and y axis. We know that on x axis we always used to write reaction coordinates, okay, and on y axis always there is a potential energy, okay. So consider here, first of all there will be alkyl halide, okay. Suppose here there is alkyl halides, then there is activation energy required to reach the for this transition state, okay. So this will be transition state 1, okay, then this will be transition state 2, and finally we get the product here, okay. So see, this will be alkyl halide plus base here, okay, alkyl halide plus base, this will be transition state 1, this will be transition state 2, and here we get product alkene, okay. Now you know that the energy required to reach the transition state is called as energy of activation, okay. Again this will be second energy of activation A, and the difference of energy between product and reactant, this is called as delta H, that is heat of reaction, okay. So this is the energy profile diagram, So in summary, in today's lecture we have seen what is E1 elimination reaction. Remember, it is carried out when tertiary alkyl halide is the starting material, okay, and this reaction goes via two steps. Step 1, there is a formation of carbocation intermediate. Step 2, there is abstraction of beta hydrogen to form the product, that is alkene. So here this is energy profile diagram. So this is all about E1 elimination. In previous video we have seen about E2 elimination. In this video we have studied about E1 elimination. In next video we will see about what are the factors influencing E1 and E2 elimination. So till then we'll stop here. Have a nice day. Thank you.